All right. So what I want to do is I want to go over some ionic compounds, more examples, because I know this can get confusing, and you really got to pay attention uh, to kind of some details as you go along. I'm going to try to be as specific as I can and stepwise. So follow along with it. This goes along with the ionic the video, also the program I wrote and I send out to you. That's a good helper. But let's go over some examples of naming and finding the formula of ionic compounds. Okay, I think this hopefully this help out. This will help out more with the ionic compounds. Okay, first thing you have to do is really make sure that you know first determine that a compound is ionic. And the way that you do that, the way that you do that is if you have a compound, and I'm going to go over some down here, is if it has a metal in it. Okay, so where are the metals? The metals are left of this zigzag line. Okay, and really all you have to worry about are the metals here and also the ones that I pointed out that you need to know, and you have to know their charges as well. Okay, so sure lead should be in here, but it's down here. I forgot, but it's Pb and it's 2 plus. So we'll get back to charges in a minute. But if the compound has an element from this column, or one of these 6, then it's ionic. Okay. So also ionic compounds will always just have will have 2 names. So let's go over some examples. Here's some names, and then we'll go over the formulas and see if they're ionic or not. Okay, silver nitrate, is that ionic? Okay, so look at silver. Is that a metal? Okay, hopefully you know it's a metal. If you're not, look in this column, and one of these 6, and sure enough, it's ionic. Okay. All right, hydrogen peroxide, is that ionic? Well, hydrogen, where is it? Okay, I know it's in the first column, but we said that hydrogen is considered a nonmetal, so this is not. Okay, ionic. Calcium, is that ionic? Is that a metal? Okay, it's in the second column. All right, so yes, this is ionic. Okay, methane. Is this ionic? No. And one way you can tell is because this one word. Okay, hydrochloric acid. Is that ionic or covalent? Well, hydrochloric. Okay, so it has 2 names in it. So is hydrochloric an metal? No. Okay. It's not in the first 2 columns or... All right. Okay, so lead chloride, is that ionic? Okay, lead. So it's 2 words, so it could be ionic. So is lead a metal? Yes. Okay, so it's left of this line, and it'd be down here. I didn't put it in this periodic table. And sulfate, is that ionic? No, it's just 1 word. All right. Okay, so silver nitrate, calcium carbonate, and lead chloride. Okay, now let's look at the formulas. Okay, formulas, again, you look at the first element, and if this guy here is a metal, then it's ionic. All right, is this ionic? No, because hydrogen's a nonmetal. Ba, is this an ionic compound? BaCl2, yes. Okay, and that's because Ba is a metal, and Ba is down here in the periodic table. I cut it off. All right, is N a metal? No, it's over here. Nitrogen. So barium chloride isn't. This isn't. CuSO4. So is Cu a metal? Yes. Okay, it's this guy, copper. Na2CO3, is that ionic? Yes, because sodium is in the first column. NH3, is that a ionic? No, because nitrogen is not a metal. And K3N is ionic because potassium is in the first column. All right. So that's the first thing you got to do. You got to make sure that you know that you have an ionic. Then once you have an ionic, you have to, if you're given the name, you have to figure out its formula. And the way to do that is determine, first of all, know if it's binary or tertiary. And the same thing goes for the formula. If you're given the formula, first of all, determine if it's binary or tertiary. So let's look further into that. So we've determined that we have. So once we determine we have an ionic compound, really you should be able to determine if it's binary or tertiary, and that will help you figure out the name or the formula. Okay, you know if you have a binary if it ends in "ide." Now there'll be one exemption of that, and that'll be hydroxide, which we'll get down in a minute. But if the name ends in "ide," you're pretty darn sure it's binary. Okay. Also, we'll just have. There's not many nonmetals. Okay. So some examples. So let's look at see if I have 3 examples here. Let's see if they're binary or not. Barium. So that's these are all ionic compounds. All right. I'm telling you that, and that they all have metals in them. Okay. Now you have to decide if they're binary or not. Okay. Chloride, so it ends in "ide," so you're pretty sure that it is binary. Calcium phosphate ends in "ate," no, not binary. Beryllium phosphide, "ide," yes, binary. Okay. All right, tertiaries. Again, they'll have a metal, and they'll have an 8 at the end, except for hydroxide. Okay, so here's an "ide" that is not a single element. So keep an eye on that. Most single elements, most ides are single elements. Like F would be fluoride, Cl would be chloride. Okay, but hydroxide is OH. Okay, or H minus. The tertiaries have a metal and a polyatomic ion. So they would be like something carbonate, sulfate, phosphate, nitrate, or hydroxide. And so let's go over some examples of that. Let's see what these are. Sodium sulfate, that is tertiary. How do I know? Because it has 8. Sodium sulfide is "ide," and that's binary. Calcium hydroxide, okay. This one ends in "ide," but remember that hydroxide is a polyatomic, so this is going to be a tertiary. And finally, magnesium phosphate is tertiary. So one way to tell if you have a tertiary is if it ends in 8, usually except for if you have hydroxide. Okay, determine if it is binary or tertiary, first of all, by formula. Okay, so let's say I give you a formula. You have to determine if it's binary or not. And one way to do that is by looking at its formula. So a binary has 2 elements. Okay, and okay, so that's the key thing. Just has 2 elements, like barium chloride, sodium phosphide. Okay, we'll get to the name in a minute. BaCl, NaP. This is not a binary. It has 3 elements. 1, 2, 3. Okay, tertiaries always have 3 elements, a metal and a polyatomic. So this is has 3 elements, Ba, C, and O, and the CO is a polyatomic. Okay, carbonate. This is also tertiary. It has 1, 2, 3. Metal, polyatomic. This is not. It's binary. Just has 2 elements. This is tertiary. It has 3 elements. 1, 2, 3. And the 2 nonmetals are polyatomic, and that's phosphate. And finally, this is neither. This is not even ionic. Okay. That's kind of a trick question. Right, so binaries have two elements only, metal and nonmetal. And tertiary has three elements. Okay, a metal and a polyatomic. And polyatomics always have two elements. All right, now let's look at naming. Okay, so if I give you a chemical formula, what is its name? And first thing we'll do is binary ionics. Okay, these are really simple. It's just you just name who's in it, the metal and the nonmetal. The metal will come first, nonmetal second. The nonmetal will change its end-ide, okay? And usually it'll just be two syllables, all right? So if you like nitrogen isn't going to be nitrogenide, it'll be nitride. Okay, don't have to do anything with the numbers. So BaCl2, you don't have to say that there's two chlorines. So all you have to do for this one, BaCl, is write down who's in it, barium and chloride, okay? So the chlorine becomes chloride. All right, Na3P is sodium phosphide. Okay, you don't have to worry about the P here, the 3. MgCl2, magnesium chloride. Okay. K2S, potassium sulfide. So it's not sulfuride, it's sulfide. CaF2, don't worry about the 2, it's going to be calcium fluoride. All right, okay. So notice is that the names do not tell you about how many of the elements there are. And then finally, the last one, potassium nitride. Okay, it's not nitrogenide or nitrate. It's potassium nitride. Okay, remember, binaries and an ide. Okay, these are all binary, so they all end in ide. Okay, and they just get their metal and their nonmetal. Okay, naming tertiaries. Okay, tertiary has a metal and a polyatomic. That's it, and that's all you have to do is name. You just have to name the metal and the polyatomic ion. So you have to know your polyatomics, and there's 5 of them. There's nitrate, sulfate, phosphate, carbonate, and hydroxide. Okay. So K2SO4, well, we know it's ionic already because these are all metals, all right? Potassium sulfate. Okay, this guy's iron, and it has nitrate, NO3, iron nitrate. Now, I left the charges off of these guys, and we'll get, when you do them, I want you to put the charges on them. So right now, just we're gonna just not have the charges. So this guy is barium. We know it's tertiary because it has 3 elements, Ba, C, and O. So this guy over here has to be polyatomic, and it's one of our 3. It's carbonate, barium carbonate. Okay, Pb3, PO4, 2. Okay, lead and phosphate. Lead phosphate. KOH. Okay, potassium hydroxide. Okay, this is the weird guy. Hydroxide is not an 8. Okay, so it's not hydroxate, potassium hydroxide. Then you have copper sulfate. And then you have sodium carbonate. Okay. Now, all right. Well, I'll write down one more. Let's say I had Ba NO3 2. Okay. This would be barium nitrate. Okay. Barium. can't write all of it. Nitrate. Okay, so notice this guy here and this guy here both have nitrate in it, and they have different amounts of nitrate. This has 3, so this says 3 NO3s, and this says it has 2 NO3s, but there's nothing in the name that tells you how many nitrates. Okay. So naming ionics, you just have to tell who's in it. If it's binary, you just tell what metal it is in it and what nonmetal. If it's tertiary, you tell what metal it is in it and what polyatomic is in it. Okay, now formulas. So formulas are harder because in the names don't give you how many of each element, so you have to figure that out. And the way you're going to do that is you're going to use the periodic table to figure out the charge of the metals. Okay, so column 1 has 1 plus, column 2 has 2 plus, and then I gave you these guys over here and their charges. And again, I left off lead. It should be Pb2 plus over here. And I guess barium would be down here. I cut that one off as well. All right. So the way to do this is given the name. We'll do binaries first. You write the element and its charge, not the metal and its charge, the nonmetal and its charge. Now, your qualification about charges: you will only put charges on ionic compounds and polyatomic ions. Okay, do not put them on any other. Don't put them on covalent compounds. So water, don't put charges. Don't put a 2 minus on oxygen. No charges on covalents. Okay, the charges will only go on the ionic compounds. Okay. All right, so back to this. So chlorine, only time chlorine will have a charge is if it's an ionic compound. If you see HCA, like P2Cl3, all right, this is not an ionic compound, all right? Phosphorus and chlorine are nonmetals. This is not ionic, so these guys don't get charges, all right? I just want to qualify that, right? Don't go flying charges all over everything. They only go on ionic compounds. Okay, so back to this. So barium, Ba2 plus, second column. Chlorine, second to last column. Right, here's the last column. Everything in that second to last column gets a -1. Okay, do that first. And then the next thing you do is you crisscross the number associated, it's called the superscript, with the charge and move them. All right, so the 2 goes over here and the 1 goes over here, so you end up with this. Okay, now I put the Cl in parentheses. You can do that or not. Okay, so this says there's 2 Cl, 1 minuses, and just like in math, whenever you have a 1 in chemistry, you can leave it off, so you can have it as like this. Okay, and typically we don't put the parentheses around the Cl, so it's Ba2 plus, Cl minus 2. Okay, so it's Ba2 plus and 2 Cl minuses. Okay, sodium phosphide. So sodium is Na plus, it's in the first column. Okay, phosphide is in the 3 minus column right here. Okay. So put those, crisscross charges, bring the 3 over here and a 1 over here, so you get this. Okay, and then again you can leave off the 1 and then you can get this. Leave the charges on. Okay, so it's Na plus, 3 of them, P3 minus, and there's only 1. Okay, magnesium nitrite. Okay, magnesium is 2 plus, it's in the second column. P is in, again, same as similar as the last one. It's in the 3 minus. Put those in. Crisscross charges. So the 3 comes here. and a 2 goes here, so you have that. And there you go. That's it. Okay. Now notice what you get here is 3 times 2. Okay, is equal but opposite to 3 times 2. Okay, so that's key here is that the superscript times the subscripts should equal each other, but opposite charges. You'll see each one of these cases. 2 times 1 is equal to 2 times 1, 3 times 1, 3 times 1, and so forth. Okay. All right, potassium sulfide. Potassium is plus, sulfide is 2 minus. It's in a 2 minus column. Crisscross charges bring 2 over here and a 1 over here. So as you get K2, K plus 2, S2, 1 minus. Okay, just not 1, not 1 minus, just 1. And you just write it out like that. Okay, barium oxide, Ba2 plus, second column. I left it off at Ba's here. And oxygen is in the 2 minus column, right there. So now if the charges are the same, you don't crisscross. So you can just leave it as it is. Okay, and then aluminum sulfide. Aluminum is Al3 plus, right here. It's one that you have to know, memorize. Sulfide is in the 2 minus column here. Crisscross charges. 2 goes here, 3 goes here. And there's the formula. Leave the charges on. Okay, don't write this as Al2S3. Now, if you in a book, they might write it like this, but I want you to put the charges in, and that's because we're going to be using charges for the next set of material. Okay, and finally, we're going to go over tertiaries and how to figure out their formulas. And here's a list that I wrote down, and we're going to come up with their formulas. Okay, again, you're going to use the periodic table to figure out the charge on the metal. And so you write the potassium, you write down the K and the plus. And then the polyatomic, you write it down and its charge, and I'd like to put it in a circle or a parentheses, and then you will crisscross the charges. So let's look at potassium sulfate. So potassium is K plus, it's in the first column. Sulfate is SO4 2 minus, and you got to memorize that. It's one of the 5 polyatomics. And then you crisscross the charge. So the 2 goes here, and a 1 goes here, and so you have K plus 2 SO4 2 minus. Okay, whenever there's just one polyatomic, you can take the parentheses off. So you can write it as this here. Okay, now one thing, remember, is this 2 minus is actually belongs to that whole SO4. Okay. Okay, iron nitrate. Iron is Fe3 plus. Nitrate is NO3 with 1 minus charge. Don't get nitrate confused with nitride, okay? Nitrate is NO3, 3 O's and 1 minus, okay? And nitride is N with 3 minuses. So iron nitrate is Fe3 plus, NO3 minus, crisscross charge, bring 3 here and 1 here, and so you get Fe3 plus NO3, 3. And there you go. Barium carbonate, okay, Ba2 plus, it's in the second column. Carbonate is CO3, 2 minus. Charges the same, though, so you can just leave them as it is, okay? And there's your answer. Okay. You could leave it as this, you could write it as this, or you could have it like this. Lead phosphate. Okay, lead is Pb2 plus, phosphate is PO4 3 minus. Crisscross the charges, put 3 here, 2 here, and so you get that. Leave the parentheses around the PO4 because there's more than one. Potassium hydroxide, potassium is K plus, hydroxide is OH minus. Remember, this is I, that's a polyatomic. Okay, there's one of each, so you don't have to crisscross. Your answer is K plus OH minus. Copper sulfate. Okay, copper Cu2 plus, sulfate is SO4 2 minus. And they have the same charges, so you don't have to crisscross. You can remove the parentheses off of sulfate because there's only one sulfate, and there's your answer. And then finally, calcium hydroxide. Calcium's 2 plus, it's in the second column. OH is minus, hydroxide, crisscross charge. Put a 2 here, a 1 here, okay. You can take the 1 off, but since there's 2 hydroxides, I'll leave the parentheses on. I almost guarantee you that I will see some students write this answer like this. Okay, and that's wrong. All right, you have to put the parentheses around. Whenever there's more than one of the polyatomics, you have to put them around, parentheses around it. Okay, so hopefully this helps you with the ionics.